Hello and welcome to this PowerPoint presentation on PIC microcontrollers instruction set. The microcontroller which we will be discussing is PIC 16F877a from Microchip. These are the learning outcomes of this presentation. At the end of the session, student will be able to identify a suitable instruction for performing a given task in an efficient way. Given a program, student should be able to choose which instruction can be used to perform that particular task. And second outcome will be student will be able to apply the knowledge of these RISC instruction set so that student can write assembly language program for PIC microcontroller. Now these are the contents of this presentation. We will have introduction, then opcode fields. So how the opcode is made up of, what are the different fields in that, then different categories means classification of the instruction, then there is a general format of instruction, and at last there will be one assignment program based on these instructions. Now let us have introduction to this microcontroller instruction set. Every microcontroller has got its own instruction set. That instruction set has got a syntax. Like microcontroller, PIC microcontroller has got an instruction set of 35 instructions compared to 8051 microcontroller. Around 100 plus instructions were there in 8051. In PIC microcontroller you will find only 35 instructions. That's why this particular microcontroller architecture is called as RISC architecture. RISC stands for reduced instruction set architecture. Before going to the instruction set categories, can you tell what is the advantage of RISC architecture over CISC architecture? Now this is the classification of instruction based on the purpose for which the instructions are used. 35 instructions are classified into 6 different categories here. The instruction type may be a move type of instruction where you want to transfer the contents from one location to the another location. Then the instruction which invokes different registers. Then different arithmetic operations can be carried out by the different instructions available. Different logical operations can be carried out. Then test, skip and jump type of instructions are there which are required to have a conditional loops, and there are control type of instructions. So this is the classification of the instructions based on the purpose for which the instructions are used. Now whenever we are having the syntax for the instruction, you will find different fields in that. You should understand what is the meaning of the fields. The F stands for file register. Whenever W is there, that will be working register. B will be bit address. So within 8-bit file register. So definitely 8 bits are there in the file register. So this B will take 3 bits in the opcode. Then K will be a literal value which will be constant or data label. Then X can be anything, that may be 0 or 1. Now one important field is D. Whenever this D bit is 0, whatever operation is carried out, the result of it is stored in the working register. Otherwise if D is 1, it will be stored in the file register. And by default you have to remember that the destination bit is 1, means whenever you are doing some operation, if you are not writing D, by default the value of D is 1 and hence the result will be stored in the file register itself. Then PC stands for program counter. You know program counter is of 13 bits for the PIC microcontroller. Then timeout bit is there and power down bits are there. So these are the different fields you will find in the instruction set of the PIC microcontroller. Now the classification is done can be done of the instruction set based on the 3 basic categories. One is called as byte-oriented instructions, the instructions which deals with the bytes. The instruction may be dealing with a bit in that particular file register, so that will be called as bit-oriented instruction. And there may be instructions which are of kind control or literal. Literal means it's like immediate addressing mode of the microcontroller where the data is available in the instruction opcode itself. So these are the three basic categories of the PIC microcontroller instructions. Now these are the general formats. So whenever you are forming the opcode, 14 bit of what we can say opcode is formed. So whenever you are storing these instructions are stored in the program memory. So how much is the size of program memory? 8K into 14. So 14 bits are stored in 8K locations, and hence program counter size is what we can say 13 bits. So 2 raised to 13 comes out to be 8K. So 8K locations are there, and at each location you can have a storage of instruction which is of 14 bits width. So in those 14 bits, for byte oriented, bit oriented, literal type of instructions, how many bits are used for the providing literal, for opcodes? So all this information is available, and this is standard information called as general format of the instruction. Now the actual instructions, so whatever 35 instructions are there for the PIC microcontroller, so let's go through the different instructions which are of kind byte oriented instruction. Byte oriented means they are dealing with the byte. So what type of instructions are available? So you have instructions for adding, you have instruction for ANDing. So this is a logical instruction, this is arithmetic instruction, but this deals with the bytes. So you can clear the contents, you can complement, you can decrement, you can have increment in the contents, inclusive or move. So transferring the contents from one location to the another location. No operation is instruction. You have rotate type of instructions available for the PIC microcontroller, where what you can do is rotate. You can rotate the contents in the left or right direction. This again one more instruction available for subtraction also. So these are the different instructions called as byte oriented instructions, which deals with the bytes of the microcontroller. Bit oriented instructions, bit oriented file register operations can be also done. Means you can deal with a particular bit of a particular file register. So here, as we have discussed, this F stands for file register. So BCF, F comma B, what this instruction will be doing? So it will take file register F, and of that file register F, B number of bit will be cleared. And then in the previous instruction set also, which is of kind byte oriented instruction, this you should note that these instructions may affect the flag bits. These are the status register bits which may get affected because of the operations. You'll find that bit oriented instruction does not affect any status bit or flag register bit. So now this is another category of instruction where you are using literal. Literal means it is sort of immediate data available in the instruction. So let us say instruction add LW. So L stands for literal. So what you are doing is the contents of working register are added with the 8-bit literal value which is provided in the instruction, and whatever is the result, that result will be stored in the working register itself. And then you know that whenever you are doing the addition, definitely you may get carry generated. This digit carry is analogous to the auxiliary carry flag of 8051 microcontroller and 0 flag. So these are the status bits which are affected. So these are the different instructions which are taking the help of some literal values. As well, there are some control type of instructions which are there in the PIC microcontroller instruction set. Now at the end, miss, you will be studying the detailed instruction set through the data sheet of the PIC microcontroller, and then at last try to complete this assignment part, where the task is you want to add the this microcontroller 16F877a is a 8-bit microcontroller, but if I want to do 16-bit addition, how this can be done? So just take down this assignment part. So two file registers are used to store 1 byte first number, and these are the two file registers which are used to store the second number. And then after storing that, what I want is I want to have the result available at 37H, 38H and 39H. So these are the references which are used for this presentation. So A microcontroller data sheet is one important resource available on web, as well as PIC reference manual is also available. So now special thanks to Walton Institute of Technology and IDP in Educational Technology, IIT Bombay, for this presentation. Thank you.